Okay, we have completed. Here we have AS chemistry. Yes. We have completed electrons, SPDF. We have discussed electronic configuration. We have discussed exemption, electronic configuration of noble gases, electronic configuration of ions, dot diagram. Now orbital filling diagram, right? Isa, can you tell me what is orbital?
So that is the place where most electrons can be found.
Maximum chances to find electron. Very good. Now orbital filling diagram. Electrons are represented. Electrons are represented by an arrow. By an arrow. Electrons spin. Electron spin. So it may be clockwise or anti-clockwise. Anti-clockwise. Let's suppose this is electron. This is another electron. So this is spin. This is representation of electron. This is anti-clockwise spin. Anti-clockwise. And this is clockwise. This is clockwise spin. Clockwise spin, anti-clockwise spin. Point number next. Orbital is represented by box. Each orbital means box has maximum 2 electron. Maximum 2 electrons. But these are the rule applied when we draw orbital filling diagram. Do you have any question regarding orbital filling diagram? Yet. Yes. Are you listening my voice?
Yes, sir, I can hear. I have no
Yes.
questions.
Okay. So Question number 1. Show orbital filling diagram. Show orbital filling diagram of the following. Show orbital filling diagram of the following. Show orbital filling diagram of the following. Can you tell me what is the spin? Can you tell me what is the spin? Movement of electron is called spin. Movement of electron is called spin. Now, first question is chlorine 17. Chlorine 17 is 1s2, 2s2. Yes, can anyone tell me the electronic configuration of chlorine?
Sir, 2p6,
2p6,
3s2,
3s2,
3p6, no,
3p6,
3p5. Wait, 6, 12.
3p5.
Yeah, it should be. Yeah.
Now, this is 1s2. This is 2s2. This is 2p. This is 3s2. Again, this is 3p. Now, fill these, fill these. 1s2, then 2s2. Now, fill like this. 4, 5, 6. Electron fill singly before being paired. Then 3s2, then 3p, 5. This is called orbital filling diagram. Are you getting my point or not?
Sir, why did you not put a pair in the last box?
Because we have only 5 electrons.
Oh, okay.
Because we have only 5 electrons, right? Now next. Number 2. Nitrogen 7. Nitrogen 7. Now, can you
So I
tell
have a
me?
question.
Yes, yes.
So in like the last block, right? Like the
Mm-hmm.
3, 5, the last block. So you know how
Mm-hmm.
there's the clockwise movement and then there's the anti-clockwise movement, right? So can we put either, or does it have to be like a specific one?
Try to make sense to draw arrows, right? If all arrows are clockwise, so first draw clockwise, then anti-clockwise. Do not mess up with some one is upward, second is downward, third is upward. So follow a sequence, right? First
Okay.
upward, second upward, third upward, then return back to the downward, downward,
So the
downward, downward.
okay, so the one that is upwards is clockwise, and the one that's downwards is anti-clockwise.
Downward is clockwise. Downward is clockwise, right? Yes, downward is clockwise because this is clockwise, right? So downward is clockwise, upward is anti-clockwise.
So sir, can it be like my choice if I want to draw clockwise first or
Yes,
anti-clockwise
yes,
first?
yes, yes, yes. It's not a certain rule. There is
Okay.
no a certain rule. 1s2, 2s2, and then 2p. Now look at this is 1s2, 2s2, now 2p, 3. So this filling is wrong. This filling is wrong. Can you tell me why? Yes, this filling is wrong.
It's wrong.
Yes, this filling is wrong and this filling is correct. Always remember electron fills singly before being paired.
Ah, okay.
Electron fill singly
Before being paired.
before being paired. This is a law. Before being paired, right? Now, rule number 3 is O8. O8. Now, oxygen 8 is 1s2, 2s2, 2p, 2p4. So, which one is correct? Yes, which one is correct?
Uh, it's going to be the second one, right?
Second one. Second one is correct because first fill then this one, and then this one. That's why this is correct. Next question from past paper 9701, variant 23, May June 2019. May June variant 23. Yes. Complete the diagram to show the arrangement of electron within the third shell of a phosphorus atom. Just this is phosphorus. So phosphorus is 15, 1s2, 2s2, 2p6, 3s2, 3p3, 1s2, 2s2, 2p6, 3s2, 3p3. So in 3s we have 2 electron and then 3p1 electron fills singly before being paired. This is 3p. This is correct way. This is correct way. Now next question 9701 variant 22 by June 2010. 2010 variant 22. Yes. Part A 1. Part A1. Yes. The diagram is given, right? So this is uh, from lithium to neon, right? So the diagram below represents the energy level of the orbital present in the atom of the second period. So all belongs to second period. So right. So you know that we have 1s2, 2s2, 2p6, right? So this is 1s2, 2s2, then 2px, then 2py, then 2pz. Whether this question has 2 marks, right? 1 mark to show orbital. This is orbital. Orbital. And second mark for principal quantum number. This is principal quantum number. This is principal quantum number. Now next part. Yes. Now two elements are given. Now two elements are given. Two elements are given, oxygen and yes. Now anyone tell me the electronic configuration of nitrogen? Yes,
Um, for nitrogen, it's going to be 1s2,
1s2,
then 2s2, and then 2p3.
2p3. So this is 1s, 2
Yeah,
electron. This is 2s,
two electrons.
2 electron, and then
2p3.
2p, right? This is 2px, this is 2py, this is 2pz.
Oh, so sir, all three of like the boxes, so they're 2px,
Yes,
2py.
yes, yes, yes. These
Box
are
represent.
boxes.
Okay.
Now oxygen. Oxygen is O8.
So it's
So
1s2, 2s2, 2p4.
2p4. So this is 1s2,
2s2,
2s2, 2px, 2py,
2pz.
2pz. So 4 electrons. Electron fills singly before being paired. So this is
Okay.
correct. Now next question. 9701. Variant 11. October, November 2011. Question number 3. 2011. Winter. Variant 11. Question number 3. Yes. Which element has an equal number of electrons which element has an equal number of electron pair and of unpaired electron within orbital of principal quantum number 2. Now you know that beryllium is 4, carbon 6, nitrogen 7, oxygen 8. Yes, beryllium is 1s2, 2s2, carbon is 1s2, 2s2, 2p2, nitrogen is 1s2, 2s2, 2p3, oxygen is 1s2, 2s2, 2p4. Now it has 1s, it has 2s.
Sir, what did they mean by principal quantum number two?
As we have discussed, principal quantum number means shell. Another name of shell is principal quantum number.
Okay.
Shell, principal quantum number, energy level, orbit. And this is 2p. This is 2p. This is 2p. Now beryllium, 1s2, 2s2. Can you tell me how many electrons are paired?
Four.
Yes, paired.
Four.
Paired
So
is
four,
two,
right?
two, two, two pairs, two pairs,
Oh, two pairs of four electrons. Yeah.
two pairs. And how many unpaired?
None.
None. So zero. Now carbon. Carbon is 1s2, 2s2, 2p2. So how many paired?
Two. Unpaired two.
Two. Two paired, two unpaired. So both are equal.
Yeah.
So do you have what the question is that in quantum number two? In quantum number two, are you getting my point?
So which would be the quantum number two, sir?
So here we this one is quantum number two. This one is quantum number two.
Oh, okay. So
So
yeah.
it means two electrons in quantum number two. Are you getting
Okay.
my point? So
Yeah.
in 2s2 we have two paired electrons. So this is 2s2, 2s2, two electrons. Now read the
Uh,
question. Now read the
I,
question again.
but sir,
Read the
if it were
question.
to say, so sir, but if it were to say like state the number of paired electrons in quantum number one and two, then for beryllium
It
it
means
would be four, right?
yes, exactly. Now
Okay.
read the question again, right? Which element has an equal number of electron pairs, and unpaired electrons within orbital of principal quantum number? Now it is written within orbital of principal quantum number two. Are you
Got it.
getting my point or not?
Yes, I am. I got it.
Okay. Now here I am writing paired electron, paired, here unpaired. Now tell me number of paired electron in it. Yes, in
In
A,
oh, in A it will be four, right?
paired electron 4.
Yeah.
Okay, equal number of electron pairs. So, okay, first I would like to draw all electrons. This is 1s2, 2s2, and then 2p3. Last one is 1s2, 2s2, 2p4, 2p4, right?
Mm-hmm.
Now, paired electron, unpaired electron in second shell only. In second shell only. Yes. Now, can you tell me paired electron in first one? Yes, Mohammed.
In the first one, there'll be two paired electrons and zero
Two
unpaired.
two paired electrons, zero unpaired, correct. And in second,
Second one will be two and two. Third one will be two and three, and the last one will be two and four.
two.
Sorry. In the sorry, yeah. In number two, it'll be two and two. In nitrogen, it'll be two and three, and in oxygen, it'll be two and two. Right?
Okay. So if we are asking about the paired electron, right? So we can say that here we have one paired, zero unpaired. If we are
Yeah.
asking, if examiner ask about the paired electron, right? So
Yeah.
here we have one paired, two unpaired. Here we
Yeah.
have one paired, three unpaired, right?
Yeah.
Here we have two paired, two unpaired. So answer number D is correct. Read the question again,
So it says electron pairs. Yeah. So two electron pairs. Number D.
right?
Correct.
Electron
Yeah.
pairs. So two electron, uh,
Correct.
2s contain two, 2p contain two electrons which are being paired in it, right? So
Uh-huh.
the correct answer is D.
Caught up. All right, sir.
Okay.
Mm-hmm.
Uh, Now I am finding another question, right? Hmm. Atom of element X have six electron. Isa, are you in the class?
Yes, sir, I am.
Okay. I am finding another difficult question. Atom of element X having six unpaired electron. Okay, write the question. Question is atom of element X have six unpaired electron. Six unpaired electrons. What could be element X? What could be element X? A carbon, B chromium, C iron, D selenium. So in the question examiner asked, find the element which have six unpaired electron. So find the unpaired electron. Carbon is 6. Carbon is 6. Chromium is 24. Iron is 26. And selenium is 34. So write electronic configuration of carbon. Carbon is 1s2, 2s2, 2p6. So 1s2, 2s2. So can you tell me number of paired electron and unpaired electron?
Carbon is
Yes.
all paired.
How many unpaired electron?
None.
Unpaired.
Yes, there's none.
Sorry, this
Three.
is 3. Uh,
Oh, if it's
Now, okay,
yeah,
now
yeah,
now tell
yeah.
me again.
Three, sir. Two, sir. Two.
2. This is carbon, so unpaired two electrons. So this is not the correct answer. Now chromium. Chromium is, you know that it is exception. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5, 4s1, 3d5, 4s1, 3d5. This is 4s1, 3d5. Now tell me how many unpaired electron? Yes. Beta, how many unpaired electron? Isa? Mohammed, are you listening my voice?
Yeah, I can hear you, sir.
Yes, how many unpaired electron?
Uh, 1, 2, 6, right?
6. So this would be the correct answer. Now iron, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Selenium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p, 4, 4p4.
Yeah.
So valence is 3d, 1, 2, 3, 4, 5. Here valence is p. So 1, 2, 3, 4, 5, 6,
There are only 4 unpaired.
4 unpaired. Here 1, 2, 3, 4. How many
T-
unpaired?
2.
2.
2. Yeah.
Nearly we are near to finish this chapter, right? So do you have any question about the orbital filling diagram?
No, sir, I don't.
Okay. So we have now summary of electron filling diagram. Summary of electronic configuration. Electronic configuration. Now always remember electron electron fills electron fill according to their energy. According to their energy. Electron fill according to their energy. Low energy fill first. So electrons fill according to their energy. So low energy containing orbital fill first. This law is called Aufbau law or Aufbau principle. So you know that which orbital come first, 3D or 4s? Yes, 4s come before 3D.
No, 3D comes before 4S, right?
Which one has low energy, 4s or 3D?
3D.
No, 4s has low energy. That's
But
why 4s fill first. You can see that 4s come before 3D. We have discussed in the class.
oh, sorry. Okay, never mind. Yeah, sorry. I thought you were
Okay.
talking about 4P. Yeah. All right, sir.
Okay. So
Yeah.
4s come before 3D
Okay.
because its energy is low.
Got it.
Similarly, 5s comes before 4D because of because 5s has low energy. This is rule number one. This is summary. Now another rule. This rule is called Hund's rule. Naming is not important. Law is important. Every orbital, every orbital has two electrons. Are you getting my point?
Yes, sir.
So according to Hund's rule, every orbital in a subshell is singly occupied with one electron before any one orbital is doubly occupied. So we have discussed electron fill singly before being paired. Electron fill singly before being paired. This is Hund's rule. For example, nitrogen 7, oxygen 8. 1s2, 2s2, 2p3. For nitrogen, 1s2, 2s2, 2p7. This is wrong because electron do not singly fill before being paired. So this one is correct. Now oxygen, 1s2, 2s2, 2p4. This is again wrong. Correct one is 1s2, 2s2, electron fill singly. You can see that singly, then being paired. This is Hund's rule. Now the last rule is Pauli exclusion. Pauli exclusion principle. Name is not important, statement is important. So each orbital has maximum two electrons. This is Pauli exclusion. This is Pauli exclusion. Yes, do you have any question regarding summary of the electronic configuration? Yes.
No, sir, I got everything.
Okay. Isa, are you in the class? I think Isa has connection problem. Now, last topic. Now, last topic is ionization energy. Very, very important. Ionization energy. Yes. Mohammed, do you know what is ionization energy?
No, not really, sir. Sort of, yeah.
Okay. Now, listen. 9701 variant 22 February March 2018. Explain what is meant by ionization energy. What is meant by ionization energy? This question is for 3 marks. Now, for 3 marks. First static for first mark. It is the amount of energy required. It is the amount of energy required. It is the amount of energy required. Point number 2, to remove an electron. To remove an electron or 1 mole of electron. Both are correct. Or 1 mole of electron. Point number 3, from gaseous atom to form gaseous plus 1 ion. Gaseous plus 1 ion. What does it mean? It means, let's suppose you have sodium, but it should be in gaseous state. When you remove this electron, sodium become positive. This energy is called ionization energy, and ionization energy is always positive. Ionizing energy is always endothermic. Ionizing energy, yeah, ionization energy is always endothermic. Ionization energy is always exothermic. Ionization energy is always exothermic. Now, examiner asked, write the equation to show ionization energy of different element. So, question, write equation to show first ionization energy of the following. You can say that it is first ionization energy. Now, questions are carbon, sulfur, fluorine, calcium, bromine. So, carbon gaseous convert into carbon positive gaseous. This is called first ionization energy. For example, it is sulfur. Sulfur convert into sulfur positive gaseous. This is called first ionization energy. Similarly, fluorine gaseous. You know that fluorine is gas. So you know that one one electron is released. So this is ionization energy of fluorine. This is called first ionization energy of fluorine because one electron is removed. Because one electron is removed. Now calcium, gaseous,
So sir, I
calcium
have a
plus.
question.
Yes, yes.
So if you have like oxygen, right, O2, then do we have to write
Okay.
one half O2 will turn into F1 plus E minus? Oh, sorry, O plus E minus.
Exactly, exactly. Now look at question number 6,
Yeah.
oxygen. So here we have oxygen. Oxygen is O2 gas. So half. So O positive gaseous. Again, one electron is removed. This is first ionization energy. Similarly, Br2 gaseous. Both reactant and product should be gaseous. Here again half Br2 gaseous. So Br gaseous positive. So this is all about the first ionization energy. Now question number 2. Define second ionization energy. Define second ionization energy. Define second ionization energy. So same definition, right? Same definition. same definition. It is the amount of energy required to remove an electron or 1 mole of electron from gaseous plus 1 ion to form gaseous plus 2 ion. From gaseous plus 1 ion to form gaseous plus 2 ion. So here sodium positive, here we have sodium 2 positive, 1 electron is removed. This is second ionization energy. This is first ionization energy. Second ionization energy is also positive. Now same question again. Write equation to show second ionization energy of the following. Write equation to show second ionization energy of the following. Now here you have carbon, right? So carbon positive gaseous, carbon positive gaseous convert into carbon plus 2 gaseous plus electron. This is second ionization energy because carbon changes from plus 1 to plus 2. Both species should be in gaseous state. Mohammed, are you getting my point?
Yes, sir, I am.
Okay. Now second is sulfur. Sulfur plus gaseous convert into sulfur 2 plus gaseous plus electron. Now fluorine positive gaseous convert into fluorine 2 plus gaseous plus electron. Same for the calcium plus 1 gaseous convert into calcium plus 2 gaseous. Bromine plus gaseous convert into bromine 2 plus gaseous plus electron. Oxygen plus gaseous convert into oxygen 2 plus gaseous plus electron. This is second ionization energy. Second ionization energy. Mohammed, can I move forward?
Sure, sir. By all means, I get it completely.
Okay, Alhamdulillah.
So, just a quick question, sir. So, is the
Yes.
ionization energy like on all stages the same for all atoms or all like elements?
No, no, it is its value is not same.
No, no, like for all elements, right? So in the first ionization energy or like the first
Hmm.
stage,
Hmm.
they will always have a plus one, right?
Exactly, exactly. Plus one,
And then in the second stage, they'll have a plus two, and that's
plus two.
applicable
But
for
from
all.
plus one,
Yeah. Okay.
not from zero, right?
Yeah, of
For
course.
example,
So go from plus
for
to two plus.
hmm, for example,
Got it.
this is calcium gaseous, right? This is calcium 2 plus gaseous, and 2 electrons are removed. This is not second ionization energy. This is not second ionization energy. Are you getting my point or not?
Yes,
This
I am,
is
sir. I
not
completely understand
okay.
it.
This is not second ionization energy because 2 electrons are removed. For ionization energy, it is necessary to remove one electron. Now, next is factors on which ionization energy depends. Factors on which ionization energy depends. There are four factors, right?
Right.
Four factor. First is nuclear charge. First is nuclear charge.
Okay.
Second is, you know that nuclear charge is number of protons. Nuclear distance. Nuclear distance means atomic radius or distance of valence electron from nucleus. Third factor is shielding. Shielding effect of inner electron. Shielding of inner electrons. And the last one is spin pair repulsion. Spin pair repulsion. Spin pair repulsion. Mohammed, can you repeat what is ionization energy?
Ionization energy is the energy that is required to make an element lose one electron, right?
Yes, exactly. To form.
To form it from a gaseous state into from a gaseous atom into a gaseous ion.
Okay. So, and what is second ionization energy?
The second one,
Hmm.
isn't it the same thing? But in this case, you tend to go from an ion to an ion, but comparatively one less particle of electron.
Mm, you can say that it is a conversion from plus one to plus two, right?
Plus
When
one to plus.
electron plus two and electrons are removed in it. Electrons are removed in it. So first factor is nuclear charge. First factor is nuclear charge. But what is the meaning of nuclear charge? Yes, Mohammed, do you know what is?
No, I'm not sure, sir.
Yes, right. First point, nuclear charge means number of proton. You know that in the nucleus we have only proton, and we also have neutron, but neutrons do not have any charge. So it has only electron. It has only a charged particle proton. So nuclear charge means nuclear charge means nuclear charge means number of protons Nuclear charge means number of protons. Number of proton. So can you tell me across the period, proton number increases or decreases?
Sorry, so
Yes.
could you repeat your question, please?
Yes, I am asking across the period. This is point number one. Now, point
Yeah,
number two, across the period, proton number increases or decreases?
it increases.
Increases. So, across the period, proton number increases means nuclear charge increases. So, as the nuclear charge increases, nuclear attraction increases or decreases? Yes. Yes, Mohammed. Mohammed, are you listening my voice?
Yes, yes, I am, sir.
Okay. Now, can you tell me as the nuclear charge increases, nuclear attraction increases or decreases?
If the nuclear charge increases, the nuclear attraction will also increase.
Also increases. Very good.
Yeah, that's because there's obviously more charge in, right? So there's more charge,
Okay.
more attraction, etc.
Mhm. So across the period, nuclear attraction increases.
Sir, is it okay if we can end the class in 5 minutes? Because I have like a math
Okay,
class. Right?
okay, 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 okay. Just 5 minutes, right? So this is
Yeah.
the first and last factor for today. Now, shell increases across the period or not?
The what, sir?
Number of shell or period.
Yes, it does increase.
Okay.
It increases
Across the period, shell increases.
across the period.
Hmm.
So period is the vertical one, right? So as you go further down, the
No,
number
no.
of shells.
Period means horizontal line.
Yeah, the horizontal ones, right?
So as you move across the period, number of shell remains same because period indicates the number of shell. Let's suppose if
Oh,
you
you
have
meant across. I thought you meant down. Yeah, yeah. If you move across, it's the
okay.
same. Yeah.
So across the period, shell remains same. Shielding of inner electron because inner electrons remain same. Shielding of inner electron remains same. So you require more energy across the period or less energy as the nuclear attraction increases. Yes. So last point is across the period shell remains same, shielding of inner electron remains same. So energy required to remove an electron across the period increases ionization energy also increases also increases also increases. Mohammed, are you getting my point or not?
Yes, I am, sir.
So should I move to past paper question or leave for tomorrow?
Sir, could you leave it for tomorrow? Because I have like a math class at 12:30 my time.
Okay, my June 2016. Mohammed, are you getting my chemistry or not? Or
Yes.
do you have any issue?
No, I perfectly understand it, sir.
Alhamdulillah, Alhamdulillah, Alhamdulillah. Right? So
Yes.
inshallah, we will meet tomorrow. Inshallah.
Okay, okay. Thank you a lot.
Okay? Allah
Okay.
Hafiz.
Allah Hafiz, sir.